Time for practice 3-5. So now we're about halfway through chapter 3, and let's review for a minute the things that you learned from the notes section for chapter 3, section 5. And here they are. You had two theorems, Polygon angle sum theorem and the exterior angle theorem. So Polygon angle sum theorem, this is for interior angles. And we're adding up all of the interior angles. And it's sort of based on the idea of connecting vertices and ending up with triangles. And however many vertices you have, take away 2, multiply it by 180, and that is the sum of your interior angles. So n minus 2 times 180. N is the number of sides. Number of sides is what the n stands for. So there's one formula. Now here's the other formula, the Polygon exterior angle theorem. I don't have to write exterior because they wrote it for me. And here's the theorem, 360 every time. So no matter how many sides you have, I won't use the extended versions here, no matter how many sides you have, you will end up with 360 degrees for all of these exterior angles when you add them all up. You can't just say that one of them is 360. We got to add every one of them, then we get 360. So let's also remember one special definition, or actually a couple special definitions here. We've got equilateral, meant that the sides are congruent. Equiangular meant that the angles are congruent. And then this really generic kind of term for something really, really special. A regular polygon is both equilateral and equiangular. So we are very used to regular polygons in our lives. We see stop signs. Oops, stop. Stop signs are examples of regular octagons because every one of those sides is congruent to every one of the other sides, and every one of these interior angles is congruent to every of the other ones. So now let's practice with regular polygons and figuring out some of these angles using our interior angle sum theorem and our exterior angle sum theorem. Behold the practice. So number 1, each of these is a regular polygon. So I have a regular triangle here for number 1, which means that every one of these sides is congruent to every other side, and more importantly for our purposes today, every angle on the inside is congruent to every other angle on the inside of the triangle. So how can we use this information to figure out what the y is and what the x is? Well, hey, it's a triangle. I could use my polygon angle sum theorem, n minus 2 times 180, or I could just remember that triangles have 180 degrees. Well, let's just practice with this, shall we? N is the number of sides. For a triangle, that's 3. 3 take away 2 is 1. 1 times 180 is 180. Yay! So on the inside of this triangle, I have 180 degrees. Now, if each of the angles are congruent, each of the angles is congruent, then any of them would have the same measure, and I can just do the 180 divided by 3, which gives me 60 degrees. And so 60 degrees is the measure of angle y. It's also the measure of this angle right in here. So I get 60 here, and I get 60 here, and the one that they cared about, that was 62. Hey, but what about the x? Now, some of you are saying, oh, I know, it's that whole remote interior angle sum theorem something. Well, yes, we could do that. We could say that x, let's get some highlighting here, this angle out here is an exterior angle, which would be equal to, oops, I can't tell that's an equal sign, can you? So this x angle is equal to the sum of these two remote interiors. Hey, so 60 plus 60. What does that equal to? Yep, 120. And now some of you are saying, well, Mrs. Mitchell, you didn't really need to go through all that because I could tell that this exterior angle here, labeled X for exterior, that is supplementary to this 60-degree angle. Indeed, you are correct. So if this is 60, how much more does it take to make a straight line? And the answer is 120 degrees. Sure enough. So we get 60 equals y, 120 equals x. Now for number 2. I'll switch ink colors so that you don't get too confused here. So we have another regular polygon, meaning sides congruent, angles congruent, and all they care about is this angle out here. Okay, well, if it's an exterior angle, I know that if I add up all of these exterior angles, I'll get what number? 360, but I only want one of them. So wait a minute, all of these exterior angles are congruent, are they not? Because all the interior ones are congruent. So if all these exterior ones are congruent, I can just figure out however many exterior angles I have and take my 360, divide it by the total number of exterior angles, and that will give me the measurement of n, because n would be just one of these many, many angles I have on the outside. Well, how many angles are there? Let's count them. 1, 2, 3, 4, 5, 6, 7. And you know what's interesting? There are 7 sides. 1, 2, 3, 4, 5, 6, 7. So I'm doing 360 because that's my exterior angle sum theorem, divided by 7. Notice how nicely a question mark turns into a 7 there? Oh yes, I agree. So 360 divided by 7, that happens to be 51 3/7. Well, that's not a very pretty number, but you can handle it. 51 3/7 degrees equals n. Okay, moving on. Same tactic here for number 3. Let me count how many sides. 1, 2, 3, 4, 5. 5 sides, so n equals 5. Now, I want this, I have to go through my polygon angle sum theorem, then divide that by the number of sides. So this is an extra step that you haven't been doing yet, but you can handle this. So if I added up all of these interior angles, I would have 5 minus 2, there's my n minus 2, times 180. How much is that? That's 540. Let me slide this over just a little more. There we go. 540. So now, what do? Well, if they all add up to 540, then I can take the 540, divide it by 5, because that's how many there are inside, and that'll give me one of them. And the key here is that it's a regular polygon, so I know that they're all congruent. So 540 divided by 5 is 108. That would be the angle measurement for A. But then what about B? Well, you can just use the supplementary angle idea here, because I've got A, which is also right down here, A. So A and B together will equal 180. So that means I've got 108 already. How much more does it take to get to 180? Well, that would be 72. So I can do some substitution here. So now I got 108 plus B is 180. Take away 108 from both sides. Oh, that was a weird 8. And B equals 72. All right. Not too bad. So I got 72 in there for B. All right, now find the missing angle measurements. Oh no, they're not regular anymore. But we know how to solve this because we have our n minus 2 times 180. Have you noticed how many times I've repeated that? Yep, because you need to memorize it. So that means that I have however many sides, 1, 2, 3, 4, 5 sides. Okay, so I do 5 minus 2 times 180. Hey, wait a minute, that's a pentagon. Doesn't look like a pentagon, not a regular pentagon. But if it has 5 sides, doesn't matter if they're congruent, we'd still call it a pentagon. So 5 sides, take away 2, that's 3. 3 times 180 sounds familiar, 540. So that means that I have to add up this and this and this and this one, whoa, that's a big angle, and this, and that'll all add up to 540. Well, if I add them all up, I've got one that I don't know. That one that I don't know, I'll let you do the math on that. Tick tock, tick tock. Are you sitting there waiting for me to write the answer? I'm not going to. So you have to figure out what x equals by doing your very own math. And now the interesting thing is, if you're not even listening to this, if you're just watching, you're going to realize that I go on to the next problem without writing the answer for number 4. So I will be checking your homework to see if you did the math for number 4. I'll give you a hint though, if you are doing it, it is a number greater than 100. Okay, now, number 5. I need to know how many sides this polygon has. That's always going to come into play here. 1, 2, 3, 4, 5, 6. It's a hexagon, doesn't look like a regular hexagon, but if it has 6 sides, that's what I call it. So n equals 6. Now I've got all of these interior angles to add up, and one that I don't know. So n minus 2, oops, let me do 6. 6 minus 2, there's my formula, times 180. That will be 180 times 4 is 720. So now if I add all these up, and incidentally, don't forget this, it doesn't write you a number, but you know that that little box means 90. So if I added all of these up, subtracted it from 720, I'll have the answer. So here, x equals, I'm not going to write it again. I'm going to let you do the math and solve that. Number 6. Hey, it's got 4 sides. So n minus 2 times 180 would be 360. And I'm going to take these 3, subtract it from 360. Sure, you could add them all up and subtract once. And you'll end up with x equal to 129. I'll start writing the answers again. All right, now number 7. How many sides does it have? That's the thing that we need to know every time. 1, 2, 3, 4, 5. N equals 5. So all of these interior angles will add up to what? Yeah, 540 again. They like these pentagons, I think. So take away the 97, the 130, the other 130, and the 54, and you get x equal to 129. Triangle. N equals 3, so the interior angles are going to add up to 180. Let me take away the 90, take away the 43, and you're left with x equals 47. Ooh, is this any harder? No, it's not, because all we have to do is add up the sides. 1, 2, 3, 4, 5, 6, 7. N equals 7. So now I've got my formula. 7 minus 2 times 180. And that's 900. So start with 900 and take away all of these, and you'll be left with x. Yay! That's supposed to be fuzzy, happy clouds around the x, but I kind of crossed it out. I'm sorry. So you're left with x equal to, I'm not going to give you the answer on that one. All right, now, for a regular 12-sided polygon, Find each of the following. 12-sided polygon, measure of an exterior angle. I will now attempt what is almost impossible, writing a 12-sided polygon. Here, I'm going to draw the opposite sides. So I've got 1, 2, and it'll be a little bit like a hexagon, but with extra sides in there. So here's how I start if I'm drawing hexagons or dodecagons. So now I've got 6 sides, and now I need a side in between each one of those. 1, 2, 3, 4, 5, 6. That is a very terrible regular 12-sided polygon. But here's the idea. Exterior angle would be extending one of the sides and checking out what happens at that vertex still. So this is what I need for number 10. And the measure of an interior angle, I'll use this one. That's what I need for number 11. Well, hey, measure of an exterior angle. If I could just figure out how much an interior one is, I can subtract that from 180 and be left with my exterior angle. What's that you say? There's another way to do it? Yes, you're absolutely right. If you've got 12 sides, then all of these exterior angles will always add up to 360, won't it? And since each one of them is congruent because they're all regular, then you can say 360 divided by 12 because I have 12 exterior angles because I have 12 sides. And you realize that they are 30 degrees each. Oh, that was much easier. I'm so glad I listened to your suggestion. So there you go, 30 degrees for the exterior angle. Hey, how about the interior one? Oh, you're quick. You said an exterior plus the interior would have to add up to 180, and right you are. So if this is 30 over here, what does this have to be? Yep, 150. Good job. So now, here is the measure of an interior angle of a regular polygon. How many sides does it have? Ooh, now they're getting tricky. So, is it 120 degrees on an interior angle, and it's a regular polygon. So that means all of the interior angles are 120. Now, let's think about this for a second here. If I have a square, and it's a very, very, very square, a regular quadrilateral, shall we say, that would be a square, then I've got 4 right angles. So that would make it 90. Fascinating. What was the triangle interior angle? Oh yeah, 60. All right, and hey, look at this. We did the 12-sided one and found that an interior angle of a 12-sided polygon is 150. So I got a bunch of things in here, and I've got my 12-sided. I lost count, sorry. Pretend that's 12-sided. And those are 150. So now, before you even start this, take a guess. How many sides do you think something with 120 degree interior angle will have? Well, it's somewhere between a 4-sided figure and a 12-sided figure, isn't it? So here's our 120 in here. So, you've made a guess? Okay. Now let's figure this out. So here's how I figure this out. Let me get a clean piece of paper. Every time we were talking about a single interior angle, we were starting with the formula n-2 times 180, which was great. But if we wanted just one, then we took whatever answer we got there and divided it by the number of sides. Okay, so here's sort of a takeoff on your interior angle sum formula, and now we can call it the single or the one interior angle formula. n-2 times 180, then divide by that same n, the number of sides that you've got. Now, they told us that one of these interior angles was equal to 120 degrees. Well, let's do some algebra on this. So I'm going to use a bigger marker too. n-2 times 180 and divided by n, and that for number, what are we on, number 12, would be 120 degrees. Okay, well, it's algebra. The object of the game is to get all the variables alone on one side of the equal sign. But I have this division thing here, so let me do this. Let me do multiply both sides by n over 1. So that makes these cancel. And now here I am with n minus 2 times 180, parentheses of course, equals 120n. Oh, great. Now I got variables on both sides. But wait, it's okay. How about some, distributive property? Yes, let's do that. So now I've got 180n minus 2 times 180, that would be 360, equal to my 120n. Now, what were we doing here? We're just trying to find one of the interior angles. So, we're getting there. Let's simplify this a little bit. Let's put the 360 over here and the 120 over here. So let me take away 120n from both sides, and I'm also going to add 360 to both sides. Why, you ask? Because that makes the 360 disappear from here and become positive, and it also makes the n's disappear from this side and show up here. So now I've got 60n equals 360. Oh, okay. Divide both sides by 60. N is 6. Okay, so one interior angle using this formula meant that my n, my number of sides, had to be 6 if each of those single interior angles is 120 degrees. So back to where we were. Here we are, 120. We used, let me write it in here, n minus 2 times 180 divided by n equals 120. Whoops, there you go. So n was 6. So six-sided figures have 120 degree interior angles. Hey, so what do you think 108 is going to be? Well, 108 on our list would be over here. Oh, I wrote that wrong. I'm sorry. Try that again. 108 would be somewhere between a 4-sided and a 6-sided figure. And if you're guessing it's a 5, you're probably right. But let's see that again. Let's do the math over here. I can use n minus 2 times 180 divided by the number of sides. In this case is going to be 108. Well, I'm going to multiply both sides by the n to get rid of it from this denominator. So now I've got n minus 2 times 180 equals 108n. Distributive property, I'll write it that way. So now I got 180n minus 360 is 108n. I'll move the 360 over here with some addition. I'll move the 108 over here with some subtraction. So now I'm at 72n equals 360. Divide both sides by 72. N is 5. You were right. Good job. I'm just going to write it in here. 5. Much better. Hey, 135. Well, you're looking at this list and you're saying 4 sides gave me 90, 5 sides gave me 108, 6 sides gave me 120, 12 sides gave me 150, so 135 is somewhere in here between the 6 and the 7. So let's set it up. We have the number of sides, which we don't know, times 180. So that's my total of all of the sides, all of the angles inside. But I just want one of them, so I'm going to divide by the number of angles, which happens to be the number of sides. And that equals 135. Now, you can do the math on that in the margin and calculate it for yourself. So n equals how much? And I'll check your answer for that. If you need to rewind and see how I did that again for numbers 12 and 13, you may. So now let's identify each item in exercise 15 through 18 below. Okay, now we need to identify a quadrilateral. Wow, how do we identify quadrilaterals? We name them by their vertices. So in here I see a triangle and I see this other thing. 1, 2, 3, 4. Hey, that would be a quadrilateral. So I'm going to start with vertex B. And I have to go in order. So B, E, D, C. I've named the 4 points, and there you go. Now, what would the name of an exterior angle be for this? Well, you're looking at it, and you're pointing to it, and you're saying, it's this one, this 90 degree. But wait, little review time here. How do we name angles? Yeah, I need, well, here we go. An angle needs 3 points. And the vertex of that angle is the middle letter. So here's the vertex, here's one of the points, here's another point. So F, A, E. What's that? Yes, you can name it the other way. You can say it's E, A, F. So I'm going to use my angle symbol, then F, A, E. The other way is absolutely correct as well. Now, we need a pair of supplementary angles. A pair. So I'm going to name the 2 angles that add up to 180. So I got something plus something equals 180. Not that, not that, not that, not that. Oh ho ho! But this with this makes a straight line. So that's where I need to be. Hey look, it's the same angle we just talked about. FAE. How do I name this angle? Well, I gotta look way out here at its vertex. BAE. So here's your answer. FAE and angle BAE. Where's a pentagon? How can I name a pentagon? Well, you name it by its vertices, just like all the others. So 1, 2, 3, 4, 5. 5 sides, 5 vertices. B, A, E, D, C. Great. And yes, you could have started at A and gone alphabetically. Very true. A, B, C, D, E. Okay. Now, a regular polygon has an exterior angle measure of 18. How many sides does it have? How do you want to solve it? What do you say? Well, exterior angles, those are always going to add up to 360. So I've got the answer to the question is 360 when I add up all of these interior angles. If each of the angles measures 18 degrees, then I need to multiply 18 by however many angles I've got to figure out what my, what did I just say? Multiply 18 by the number of angles, which happens to be the number of sides, and all of those added all together or multiplied that many times would add up to 360. Okay, so do you know where I'm going to go from here? I bet you do. So you do the math on that one, and that's it. You're done. Have a great day.